Continued. Yeah. So we know the value of R. R is how much for this R particular? No, it's 6, right? For this one, L is how much? 2. Sorry, this, yeah, circuit. So this is 3, this is 1 farad. 3, 3, yeah, that was 2. So after substituting the value, get L is equal to 2, is equal to 1, R is equal to 3, correct? So it would be how much? Lambda square plus 3 by 2 plus 1 by 2 is equal to 0. So in every case of RLC, we have to make this quadratic equation. Okay? And this quadratic equation will be make it from the t greater than 0. Like step number 1, t less than 0, calculate initial condition. Initial condition means Vc of 0 minus or and IL of 0 minus. Now in the step number 2, for t greater than 0, apply KVL, then you will get something in d by dt. Okay, then convert it into the quadratic equation like ax square plus bx plus c. So in this case it would be a lambda square plus b lambda plus c. Okay, now after that we have to check whether the roots are equal, real, imaginary, negative. So according to that, we'll get it to know that which condition it is: overdamped, underdamped, critically damped. Okay, so now you will have lambda square plus 3 by 2 lambda plus 1 by 2 is equal to 0. Correct? Now tell me the value for the lambda. You will get 2 lambda, lambda 1 and lambda 2. I'll be back in a minute. Okay. Done? Ax square like minus b plus minus root of b square minus 4ac. So we'll use minus b plus minus root of b square minus 4ac divided by 2a. So minus 3 by 2 plus minus root of 3 by 2 ka square minus 4 into 1 into c is 1 by 2 into 1, right? Now solve it and then tell me the value. Once you will consider the positive sign, then you need to consider the negative sign. Tell me. Hmm.